So exam number 2, problem number 4 is a pair of clicker questions. The first one has you pushing with the same force F on two different pucks or disks, one of mass 2m, the other of mass m, over a distance d from x equals 0 to x equals d, and you're asked which disk has the greater energy when it crosses the finish line. So the proper way to address this question is to use work energy concepts and say, well, okay, if you press or move something over a distance d with a force F, you do an amount of work Fd, F times d. There's no need to do an integral in this case. And we also know that that equals the change in energy. So you start with a zero kinetic energy, so this will just be equal to the final kinetic energy in both cases. And so if you push with the same force over the same distance, that tells you that K final is the same for both. And that's answer C. So write C and circle it. So there's no need to do complicated constant acceleration formula, etc. It's possible to do it that way correctly, but it's a whole lot more work to do that than to just rely on this very simple concept. Work is defined as F times d. If the force is constant and d is in one direction, work is also the change in kinetic energy, and so the work has to be done is the same for both. Okay. So some students didn't write out the two key concepts. The things I was looking for was the same force and the same distance. There were many people who said, well, the force is the same, so the work's the same. Or a few who said the distance is the same, so the work is the same. You really have to say the product of the two is the same in order to analyze the situation. Sometimes I took off points because it wasn't clear you understood that, and sometimes I didn't because you said enough that I thought I could infer that you realized it was the same distance, since the problem says that, but it also says it's the same force. So to really ensure that you got full credit, you need to make this argument and pointing out that both of these are the same. So clicker question number 2, okay, has you pushing on a block of mass m, okay, with a force called F push, and this problem says the block is at rest on the surface, and it gives you the coefficient of static friction, and the block does not move. And so you have to pick which of these possible answers is the correct one. There's always the correct one. And the correct one is always E. E says the magnitude of the force of static friction equals the magnitude of the pushing force. And of course, there's one point for the analysis of this, or the explanation, and the proper explanation relies on the word or the phrase does not move, which means that A equals 0, the acceleration is 0, which tells you that the sums of forces equals 0, which implies this. There are two forces in the x direction, so these must be equal in magnitude, of course, opposite direction. So this is the reasoning I was looking for. There were quite a few students who said, well, that's an action-reaction pair, so they're equal and opposite. That's just wrong. F push and the force of friction are not an action-reaction pair. Remember, action-reaction pairs act on different objects. Both of these act on the same object. So that's not correct that they're an action-reaction pair, and that's not the correct reasoning. This is what you needed to say in order to earn full credit for this problem. So that's it for the clicker questions.